Hello students, myself Kale, Rayat Shikshan Sanstha's RBNB College Rampur. 11 Science Mathematics Part 2, Lecture number 5, Chapter number 1st, Complex Numbers, Exercise 1.1. In the previous video lecture, we have completed here question number 1st to question number 18. Also 23rd problem is completed. Now today we start here remaining problems. Let us see here problem number 19th. If a plus 3i upon 2 plus ib is equal to 1 minus I, then we have to show that 5a minus 7b is equal to 0. So firstly consider this part. We have given this part, and from this part we have to show that 5a minus 7b is equal to 0. So consider a plus 3i divided by 2 plus ib is equal to 1 minus I. Now carry this 2 plus ib to the right hand side, and therefore we get a plus 3i is equal to 2 plus ib into 1 minus I. Now take the product of right hand side. We get here a plus 3i is equal to 2 into 1, that is 2 into minus I minus 2i plus ib into 1 plus ib, and here plus minus minus ib into I, that is I square into b, I into I square, and b as it is. So right hand side is 2 here plus b minus 2 or minus 2 plus b, this minus 2 and this plus b, take I common, so I minus here I square is minus 1 into b. So we get here 2, this minus minus plus 1 plus b, so 2 plus b, this is the real part, plus here minus 2 plus b into I, and left side is here a plus 3i. Now on the left hand side it is a complex number, right hand side also complex number. So these two complex numbers are equal, so equating their real parts and imaginary parts. So equating real and imaginary parts. Therefore here real part is a, so a is equal to 2 plus b. A is equal to 2 plus b, and here coefficient of I is 3, here coefficient of I is minus 2 plus b, so minus 2 plus b is equal to this 3. So carry this minus 2 on the right hand side, so b is equal to 3 plus 2, and therefore b is equal to 5. So we get b as 5. Now put the value of b in this equation, we get the value of a, and therefore a is equal to this 2 plus b is here 5, 2 plus 5, that is 7, so a is equal to 7. So we get a as a 7 and b as a 5. Now we have to show that here 5a minus 7b is equal to 0. So consider here LHS. So LHS is equal to 5a minus 7b. So this is equal to 5, put the value of a as a 7 and b as 5. So a as 7 minus 7, b as 5. So this is equal to 5 7s are 35 minus 7 5s are 35. 35 minus 35, it is equal to 0, which is nothing but the RHS. So it is equal to RHS, hence proved. Now next problem number 20. If x plus iy is equal to under root of a plus ib upon c plus id, under root of a plus ib upon c plus id, means we have given this x plus iy is equal to under root of a plus ib divided by c plus id. Then we have to prove that x square plus y square to the bracket square x square plus y square to the bracket square is equal to a square plus b square upon c square plus d square. We have to prove this. Now what is given here? X plus iy is equal to under root of a plus ib divided by c plus id. So take this to prove this. That we have to prove the equation x square plus y square is equal x square plus y square bracket square is equal to right hand side. So this is the given part. So consider here x plus iy is equal to under root of a plus ib divided by c plus id. Now here it is square root, so we have to remove this square root. So squaring on both sides, and so we get here x plus iy bracket square is equal to, on the right hand side this square root and square get cancelled. So on the right hand side there is a plus ib divided by c plus id, and therefore we get here left side square it, a plus b bracket square using the formula a plus b bracket square, that is a square plus twice ab plus b square. So a means x, so x square plus b, twice ab, that is 2 into x into iy, 2 into x into iy, plus b square means square of this, plus I square into y square. On the right hand side here there is a division of complex number a plus ib divided by c plus id, means we have to divide by c plus id, which is the complex number. When we divide by complex number we take its conjugate and multiply to numerator and denominator. So write this as it is, that is a plus ib divided by c plus id into multiply by the conjugate of this, that is c minus id divided by c minus id. We know how to take the conjugate. We change the sign of imaginary number. Here imaginary number is id, so its sign is plus, we take minus, and so we get here this x square plus 2xy into I, and plus here I square is minus 1. We know the power of I, that is I is under root of minus 1, I square minus 1, I to the power 3 minus I to the power 4, 1. So I square is minus 1 into this y square is equal to, now take the product of numerator divided by product of denominator. So a into c, firstly we multiply a to this and then plus ib to this. So a into c, that is ac. Here a into minus id, so minus adi. Then multiply by ib, so ib into c, here plus, so plus bc into I, then here plus and minus, so minus b into d, that is bd, I into I, that is I square, and divided by, in the denominator we have to take the product of this and this, both are conjugates of each other, so here plus sign, here minus sign, so a plus b into a minus b. What is the formula? A plus b into a minus b is equal to a square minus b square. So a means here c, so c square minus b square, b means here id, so I square into d square. So we get here this x square as it is, this minus 1 into plus, that is minus, and this y square, we write a real part firstly, and here plus this 2xy I. Now on the right hand side it is equal to this ac. Now here we write plus bci minus ADI minus here BD into I square is minus 1. We know I square minus 1 divided by this C square minus here I square is minus 1 into D square. So we get here x square minus y square x square minus y square plus 2xyi is equal to, on the right hand side, this AC and this minus minus plus, AC minus and minus plus, so AC plus BD, AC plus BD. Then from these two take I common, so plus BC minus AD, plus BC minus AD into I, and whole divided by here C square, this C square, and minus minus plus, so plus D square, C square plus D square. And therefore we get here x square minus y square plus 2xyi is equal to, we divide this AC plus BD by C square plus D square. So we divide a real part and imaginary part separately by the denominator. So AC plus BD divided by C square plus D square, and plus this BC minus AD divided by this C square plus D square into I. And now observe here, on the left hand side we have the complex number, that is x square minus y square is real part, 2xy is the imaginary part. Here also this is real part and this is imaginary part. So equating real parts and imaginary parts, equating real and imaginary parts. So we get here x square minus y square is equal to, here real part is AC plus BD divided by C square plus D square, and imaginary part, that is coefficient of I, it is equal to 2xy. 2xy is equal to here BC minus AD divided by C square plus D square. And now here observe, we have to prove that x square plus y square bracket square is equal to this. So we consider here, as we know that, as we have x square plus y square to the bracket square is equal to x square minus y square to the square, x square minus y square to the square, whether both sides are equal. Now see on the left hand side, x square to the square plus 2 times x square into y square and plus y square to the square using the formula a plus b bracket square. On the left hand side it is x square to the square and plus y square to the square present, but middle term is here minus 2 times x square y square, and here middle term is 2 times x square y square. So to match both the side, we have to cancel this minus 2 times x square y square, which is the middle term. So we take here plus 2 times x square y square, then that middle minus 2 times x square y square get cancelled. But here on the left hand side there is plus 2 times x square y square, so we have to add again plus 2 times x square y square. Means here if we take 4x square y square, then both the equations are same. Get it? Why we use this? Because we know the formula of x square minus y square, also the formula of 2xy. So we adjust this formula. So x square plus y square bracket square is equal to this x square minus y square bracket square is equal to 4x square y square. So we write here, we know the value of x square minus y square. Before that we write this plus 4x square y square as a 2xy bracket square, and this part x square minus y square bracket square as it is. Get it? Now here next we consider this part. Therefore x square plus y square to the square is equal to, put the value of x square minus y square. X square minus y square is AC plus BD. AC plus BD divided by C square plus D square. C square plus D square. And its square, here square, so take square. Get it? X square minus y square and its square. Plus here, put the value of 2xy, that is BC minus AD. BC minus AD divided by c square plus d square and bracket square. Get it? So we get here AC plus BD bracket square. We take the numerator square using the formula A plus B bracket square. We take here direct expansion. Here numerator square upon denominator square. In the denominator here c square plus d square bracket square. And now we expand directly this. This is a square c square plus 2 times AC BD plus here b square d square. We expand numerator. Plus here also this c square plus d square bracket square. C square plus d square bracket square, because here square, so numerator square upon denominator square. We write denominator square. Now numerator square, that means BC minus AD bracket square. Using the formula A minus B bracket square, expand it. So it is first term square, that is B square C square minus 2 times product of these two, that is BC into AD, and then plus second term square, that is A square D square. Get it? Now denominator is same. Denominator is same, so we add a numerator, and therefore we get here denominator same. We write c square plus d square bracket square. C square plus d square bracket square. Now we add numerator, that is a square c square plus twice a b c d plus b square d square, then plus here this b square c square, then minus twice a b c d, that is a b c d, and plus here a square d square. Now this plus twice a b c d and minus twice a b c d get cancelled. Now here a square plus c square and here b square plus c square, from these two take c square common, and therefore we get here a square plus this b square. Here c square, here c square, so we take c square common. From remaining two terms, that is b square d square, here also a square d square. From this we take d square common, here d square and here d square. So here the coefficient of d square is b square, here coefficient of d square is a square, means plus a square, this a square and this b square. We write a square firstly and then b square into d square. Get it? So divided by c square plus d square bracket square. Now again here a square plus b square, here also a square plus b square, we take common, and therefore we get a square plus b square common, and in second bracket this c square plus this d square divided by c square plus d square bracket square. Here bracket square means this appears two times, so this c square plus d square get cancelled to this, and so lastly we get here a square plus b square upon c square plus d square, and we have to prove this. This is the right hand side. So hence we have proved x square plus y square to the square is equal to a square plus b square upon c square plus d square. Hence proved. So in this way we have completed the 20th problem. Now 21st problem here. If a plus ib, 21st problem, if a plus ib is equal to, if a plus ib is equal to 1 plus I upon 1 minus I, 1 plus I upon 1 minus I, prove that a square plus b square is equal to 1. Then prove that a square plus b square is equal to 1. Means we have given here a plus ib is equal to 1 plus I divided by 1 minus I, and from this we have to show a square plus b square is equal to 1. So consider a plus ib is equal to 1 plus I divided by 1 minus I. Now here it is the division of two complex number, and we know that when there is a complex number in the denominator, we take its conjugate and multiply to numerator and denominator. Conjugate of 1 minus I, change the sign of imaginary number, that means take here plus. So we multiply by 1 plus I to numerator and denominator. So it is equal to 1 plus I divided by 1 minus I, as it is into 1 plus I divided by 1 plus I. Left side is a plus ib. So a plus ib is equal to, now take the product of these two. That is 1 plus I into 1 plus I. So 1 plus I bracket square, 1 plus I bracket square divided by 1 minus I into 1 plus I, using the formula a plus b into a minus b, that is a square minus b square. So it is 1 square minus b means here I square. Now here expand this 1 plus I bracket square, therefore we get here a plus ib is equal to 1 square 1 plus 2 into 1 into I, that is 2I, plus I square divided by, here 1 square is 1 minus I square is minus 1. So we get here a plus ib is equal to 1 plus 2I minus I, because we know that I square is minus 1, here minus 1, I square is minus 1 divided by, here 1 minus minus plus 1 plus 1, that is 2. This plus 1 and minus 1 get cancelled, and therefore we get here a plus ib is equal to 2I upon 2. This 2 and 2 get cancelled, so a plus ib is equal to I. We write this I as a plus ib is equal to, we write I as 0 plus I. And now equating the real parts and imaginary parts. So equating real and imaginary parts. So we get here a is equal to 0, real part a is equal to 0, and b is equal to coefficient of I, that is 1, b is equal to 1. Now we have to show that here a square plus b square is equal to 1. So consider a square plus b square. Now put the value of a, that is 0, so 0 square plus b square means 1 square. 0 square is 0 plus 1, so it is equal to 1. This is the solution, hence we have proved here, hence proved. Now here next problem, question number 22. Show that root 7 plus I root 3, root 7 plus I root 3 divided by root 7 minus I root 3, root 7 minus I root 3 plus root 7 minus I root 3 divided by root 7 plus I root 3 is real. We have to show that this is real. Means in this problem we have to remove I here. We take only addition. Then whatever may be the solution, we see whether this is a real number. Here show that means it is a real number. So consider, let here root 7 plus I root 3 divided by root 7 minus I root 3 plus root 7 minus I root 3 divided by root 7 plus I root 3. Now we have to take the addition of these two rational number or rational part. Here take the product of these two plus product of these two divided by product of these two. That means 7 plus I root 3 into 7 plus I root 3. So we write here 7 root 7 plus I root 3 this into this, so bracket square, plus product of these two, that is root 7 minus I into root 3 bracket square, divided by product of these two, that is root 7 minus I into root 3 into root 7 plus I into root 3. So this is equal to, now expand this using the formula a plus b bracket square, that is a square root 7 square, that is 7, plus 2 times root 7 into I into root 3, plus square of this, that is I square into root 3 square, that is into 3, plus here expand this root 7 square, that is 7, minus 2 times this, because a minus b bracket square minus twice ab middle term, so minus 2 into this root 7 into product of this I root 3 and plus b square, that means I square into root 3 square is 3, divided by using the formula a minus b, a plus b, that is a square minus b square. A means root 7 square minus b square means I square and root 3 square. So it is equal to, now this 7 plus 7, this 7 and plus 7, or firstly we write like this 7 plus 2 into root 7 into root 3, 7 3s are 21 into I square is minus 1 and here minus plus become minus, so minus 3, then here plus 7, then minus 2, here root of 7 3s are 21 into I and plus, and here this I square is minus 1, so plus minus minus, and this 3 divided by this root 7 square means 7, here minus I square is minus 1 and root 3 square means square root and square get cancelled, here 3. So we get here it is equal to, now this 7 plus 7 6, 7 plus 7 14, 7 plus 7 14 and minus 3 minus 3 minus 6, minus 6, and this plus 2 root of 21I and this minus 2 root 21I get cancelled to each other because this plus and this minus. So 7 plus 7 14 minus 3 6 divided by 7 plus 3 minus plus. So 7 plus 3 we get like this. So it is equal to 14 minus 6 8 divided by 10. 7 plus 3 10. So 8 divided by 10 we divide by 4. So 2 4s are 8 and 2 5s are 10. See, this is the answer of this addition. And now see here, there is no I, imaginary part is not present here, and therefore this is a real number, it is a real number. So we write here which is real number, which is real number. This is the solution. So next here 23rd problem we have seen in the previous video lecture. 18th problem and 23rd problem are same. Now the last question of this exercise, that is question number 24. Find the values of x and y which satisfy. Question 24. Find the values of x and y which satisfy the following equations, which satisfy the following equations. In bracket, x comma y belongs to R, means x and y, these are real numbers. So first problem, x plus 2y x plus 2y plus 2x minus 3y into I plus 4I is equal to 5. Now here we have to find the value of x and y. See here, this x plus 2y is a real part. 2x minus 3y into I, this is the imaginary number. Here also imaginary number. So we carry this 4I to the right hand side and both side becomes the complex numbers, and then we equate the complex number, that means real part and imaginary part. So solution of this, consider, let x plus 2y plus 2x minus 3y into I is equal to 5, carry this, so minus 4I. And now here both sides are the complex numbers, equating its real part and imaginary part, equating real and imaginary parts. So here real part is x plus 2y, so x plus 2y, it is equal to here real part 5. Here imaginary part, that means coefficient of I, it is 2x minus 3y, and here coefficient of I minus 4. Now here there are two linear equations in x and y. There are two unknowns x and y, and such a type of linear equations we have solved in the school level, in the 10th standard or 9th standard. We make the coefficient of one variable same, x or y, and we find the value of another variable. We call this equation as first equation, this equation as second equation. Now here we multiply this equation by 2, suppose, because here coefficient of x is 2. We multiply by this equation by 2 and subtract 1 minus 2. So taking 2 into equation first, 2 into equation first minus equation second. Now multiply this equation first by 2, so 2 into x, that is 2x, plus 2 into 2, that is 4y, is equal to 2 into 5, 10. Take equation second as it is, that is 2x minus 3y is equal to minus 4, and we have to subtract this. So here we change the sign of this equation second. We here take here minus, because this is plus, so minus, here this minus become plus, this minus become plus, and now here this plus 2x and this minus 2x get cancelled. Now here plus 4y and plus 3y, that is equal to 7y, and here 10 plus 4, that is equal to 14. So we get here from this equation we get y is equal to 14 upon 7. 14 upon 7 means y is equal to 7 to the 14, so y 2. Now we put the value of y in equation first or in equation second. So from 1 x plus 2y, so x plus 2 and y is 2, so 2, and right hand side is 5, so it is equal to 5. So here this plus 2 to the 4, carry this 4 on the right hand side, so x is equal to 5 minus 4. So we get here x is equal to 5 minus 4, 1. Hence we get x as 1 and y as a 2. So lastly right here, hence x is equal to 1 and y is equal to 2. Now second problem in this question, second problem, x plus 1 divided by 1 plus I plus y minus 1 divided by 1 minus I is equal to I. Right hand side is I. So solution of this, we take the addition of the left side, that means take the product of these two plus product of these two divided by product of these two. So it is equal to, therefore x plus 1 into 1 minus I, x plus 1 into 1 minus I plus 1 plus I into y minus 1 and divided by this 1 plus I into 1 minus I. 1 plus I into 1 minus I is equal to right hand side is I. Take the product, x into 1 x into minus I minus xi plus 1 into 1 1 into minus I minus I. Now here 1 into y that is y, 1 into minus 1 minus 1, I into y plus I into minus 1 minus I, and divided by this 1 plus I into 1 minus I, that is equal to 1 square minus I square, using the formula a square minus b square, a plus b, a minus b, a square minus b square is equal to I. Now here we get this x real plus this y, it is real, and this minus 1, and now here this minus xi, so plus in the bracket minus x, now plus iy, so plus y, and here minus I, so minus 1 into I, and whole divided by 1 square, that is 1, minus 1 I square, that is minus 1 is equal to I. Now this in the denominator 1 minus minus 1, that is 1 plus 1, that is 2, carry to the right hand side, it become 2I. So we get here this x plus y minus 1 plus minus x plus y minus 1 into I is equal to 2I. This is 2, so it is 2I. And 2I is nothing but, we write here 2I as 0 plus 2I. We write this 2I, this 2 into I, this is 2I. Getting? And we write here 0, so 0 plus 2I. So equating here real parts and imaginary parts. Equating real and imaginary parts. So we get here x plus y minus 1, x plus y minus 1, it is equal to, on the right hand side it is 0, and the coefficient of I, that is minus x plus y minus 1 is equal to here 2. The coefficient of I on the right hand side, it is 2, and minus x plus y minus 1. So here x plus y is equal to 1, we call this as equation first, and here minus x plus y is equal to, carry this minus 1, it become plus 1, so 2 plus 1, that is 3, we call this as equation number 2. And now see here, x plus y is equal to 1, minus x plus y is equal to 3, here plus x, here minus x. So we add equation first and second, adding first and second, adding first and second. So we get here, we may write like this, x plus y is equal to 1, here minus x plus y is equal to 3. So we add, so this plus x and minus x get cancelled, plus y, that is 2y, so 2y is equal to 1 plus 3, 4, so y is equal to, carry this 2, so 4 upon 2, so y is equal to 2 to the 4, we get y as a 2. Now put the value of y. Put here y is equal to 2 in equation, suppose first, in first. So x plus y is equal to 1, so x plus y as a 2 is equal to 1. So x is equal to 1 minus 2, so x is equal to minus 1. Hence we get here x is equal to minus 1 and y is equal to 2. We again check here x minus xi, x minus xi plus 1, x plus y minus x plus y, and this minus 1. Now here, see here, here also plus 1. here also plus 1. This plus 1 and minus 1 get cancelled. Plus 1 and minus 1 get cancelled. So here x plus y in the bracket minus x plus y minus 1 into I and divided by 1 minus minus 1 is equal to I. Here this minus 1 get cancelled. Here plus 1 and minus 1 get cancelled. We consider here x plus y and this minus 1, but we have to consider this plus 1 also. So x plus y. So x plus y. So equating real parts and imaginary part. Here x plus y is equal to 0. That is x plus y is equal to 0. And therefore we get here, we add this. So here x plus y is equal to 0 and minus x plus y minus x y minus x and minus, here minus I and minus I minus 2. Here it is minus 2. Here it is minus 2. Here it is minus 2 and this become plus 4. And now here it is plus 4. So I plus I, 2I is equal to 4. So y is equal to 4 upon 2. So y is equal to 2. But here the value of x get changed. First equation is x plus y is equal to 0. So on the right hand side here it is 0. And now so x is equal to minus 2. We carry this plus 2 and it become minus 2. Hence x is equal to minus 2. Hence x is equal to minus 2 and y is equal to 2. So correct this problem. Here plus 1 and minus 1 get cancelled. This minus I and minus I minus 2I. So minus 2 into I. Firstly minus 2 and then take I common. So in this way solve this problem number 2nd of question number 24th. So remaining here there are remaining 3 problems in this question number 24. You solve these 3 problems yourself. Same problems, we have to find the value of x and y. So we stop here. Thank you.